Okay, so topic 2, we spent a day on arithmetic sequences, and topic 3, we spent a day on arithmetic series, but we haven't looked at geometric sequences specifically or geometric series specifically. We've looked at arithmetic for both of them, but not geometric. Okay, so we're going to look at both of those today, geometric series and geometric sequence. Remember, a sequence would just be a list of numbers and a geometric uh, that are geometric, and a series would be those numbers added together. All right, so a geometric sequence formula. Okay, so how can you find the nth term of a geometric sequence? Very similar to the arithmetic one, except it's multiplication, and instead of a common difference, it has a ratio. So the nth term is equal to the first term times the common ratio raised to the n minus 1 power. Where a1 is the first term, r is the common ratio, which you can find by taking a term and dividing by the previous term. An is a specified term, could be the last term, whatever the term is, and n is the number of terms. Let's use this to write a rule or model that can be used to describe a geometric sequence. All right, so first term 2400, the common ratio is 1 over 4. We need to write the formula and then use that formula to find the seventh term. Okay, so a sub n is equal to the first term, which in this case is 2400, times the ratio, which is 1 over 4, to the n minus 1 power. All right, so that's the formula. And I can use this formula to find any term. So for example, I want to find the seventh term, a sub 7, is equal to 2400 times 1 over 4 to the 7 minus 1 power. Okay, so that's 2400 times 1 over 4 to the 6th power. So let me calculate that. So 1 over 4 to the 6th power and we do want to use it as a fraction. Okay, so that's 2400 times 1 over 4 to the 6th power, so that's 1 over 4 to the 6th power, which is 4096. That leaves us with 2400 over 4096. And then we do want to simplify this. So I know that both of them are divisible by 2. Okay, so 2400 divides 2 1200 times. 4096 simplifies to 2048. Okay, this can still be simplified. I need to keep dividing it by stuff. Okay, so I'm just going to keep going with 2. Maybe they're both divisible by 4. They are. I think they might both be divisible by 8, actually. They are. Let's try and see if they're both divisible by 16. Yeah, they are. So 75. So 16 goes into 1200 75 times. And 16 goes into 20, 40, 80 128 times. And I think this is simplified because the only thing that goes into 75 is 5 and 25 and 3. 25, yeah, 25 times 3. And I don't think 3 goes into 128. No, it doesn't. And 5 definitely doesn't. So this simplifies to 75 over 128. That would be the sum or sorry, that would be the seventh term. 175 over 128. Okay, so number 2, find a sub n. So it gives us a1, which is -4, r, which is -2, and n, which is 8. So there's 8 terms. So what it's telling us to find is actually a8. So first let's set up the formula. An is equal to -4 times, so the first term, times the ratio, which is -2, to the n minus 1 power. So the 8th term would be equal to -4 times -2 to the 8 minus 1 power, which is -4 times -2 to the 7th power. Okay, so -2 to the 7th power. See what that is. So that's -128. We got -4 times -128, which is 512. Okay, so the 8th term in this sequence would be 512. Now, we also have a formula for a geometric series, okay? And this up here is the formula for a geometric series, okay? So a series is different because it adds together the numbers in the sequence. It adds them together. So, and this is a finite series, okay? So it has to have a finite number of terms. So the sum is equal to the, in the numerator, a1 times 1 minus r to the n divided by 1 minus r. Okay, it's kind of a complicated formula. There's a lot of stuff going on. But you just need the first term, the number of terms, and the common ratio. Okay, so number 3, the first term is 256, the ratio is 1/2, and the number of terms is 9. Okay, the sum of those, the series, would be a1, which is 256, times 1 minus r to the n, so 1 minus 1/2 to the 9th, over 1 minus half. Okay, so S of n is the sum, the series, 256 times 1 minus 1/2 to the 9th. So that would be 1 over 2 to the 9th. So 1 over 512 over 1 minus 1/2, which is 1/2. Okay, we'll keep simplifying this. So 256, 1 minus 5 over 12. So 1 minus 1 over 512. Well, 1 is the same thing. If we make that a common denominator, that would be 512 over 512. So it's 512 over 512 minus 1 over 512. So it's a 511 over 512 over 1/2. Okay, so we have 256 times 511, which is 130,816. So that's this times this, the numerators. And the denominator I have 512, and then it's divided by 1/2. Okay, so let me rewrite this over here so I have some room to simplify it. So 130,816 over 512 divided by 1/2, which means it's multiplied by 2 over 1. So that's 261,632 over 512, which is 512. and 11. So the sum of this finite series is 511. Okay, a little bit more complicated to calculate, but it still can be done. You just have to do the steps appropriately. You could do this with decimals, okay, if you wanted to, but it would be a lot more difficult to do this with decimals. It's a lot easier just to do with fractions. You may also, just like the arithmetic sequences, or sorry, the arithmetic series use summation notation, it is possible for the geometric series to use summation notation as well. Okay, so in this case we have, and it's the same thing, plugging in 1 determines the first term, plugging in 7 determines the last term. Okay, so let's see what is this series. We need the first term, we need the common ratio, and we need the number of terms. Well, all of the other stuff is here. Okay, the first term, well, if you plug in 1, you get 1 minus 1, which is an exponent of 0. Negative 3 to the 0 is 1. So this is always going to be the first term. Well, not necessarily. Sorry, not necessarily. Let's just plug in 1. Okay, so the first term, which is a1, you get by plugging in the lower limit. That's 4 times negative 3 to the 1 minus 1. 4 times negative 3 to the 0, which is this 4 times 1, which is 4. Okay, so the first term, 4. The ratio is right here, negative 3. Okay, so the ratio is negative 3. The number of terms you find the same way as before. You subtract these and add 1. So 7 minus 1 plus 1, which is 7. Okay, so now that I have all of this, I can plug it into the formula. So sum of the series is the first term times 1 minus r to the n, so negative 3 to the 7th, over 1 minus r, so 1 minus negative 3. So this is 4 times, let's see, negative 3 to the 7th power. Is negative 2187. So this is 1 minus negative 2187 over 1 minus negative 3, which is 1 plus 3, which is 4. Okay, so this is, well, those 4s are going to cancel actually. So all we have is 1 minus negative 2187, which is 1 plus 2187, which is 2188. So that would be the sum of my series here. Okay, so from term 1 to term 7, using this formula for the series, this calculates the sum of that series, and that's what we get. We get, make sure I've done all my calculations properly, get 2188. Okay, not bad. Now, word problem for the series, okay, just like arithmetic series had word problems, particular word problems, geometric series can as well. You rescued the king's daughter and he is offering you a reward. The first option is receiving 1 million all at once. The second option is getting the reward over 30 days, starting with 1 cent the first day, 2 cents the second day, 4 cents on the third day, and so on, receiving twice as much each day. How much is the second option worth after 30 days? Okay, so the second option looks something like this. 1 cent plus 2 cents on the second day, plus 3 cents on the third day, okay, all the way until the last day. Okay, I don't know how much they're getting on the last day. Luckily, we don't need to know how much they're getting on the last day to use the formula. Okay, so I can see here, they said it's doubling each time. It's being multiplied by, whoops, sorry, this is not 3 cents, 4 cents, okay, because it's doubling each time. 1 cent times 2 times 2 times 2, it's doubling each time. So the ratio is 2. The first term is 1 cent. And the number of terms is 30 days. Okay, so it's 30 days. So all I have to do is use the formula to calculate that, and it'll tell me how much that second option is. So the sum is the first term, 0.01, times 1 minus 2 to the n, so 2 to the 30, over 1 minus r, so 1 minus 2. Doing some math, we got 0.01 times, let's see what 2 to the 30 is. It's a very large number. I need some room for it, actually. So it's 1073741,824. Very large number. And that is divided by 1 minus, or sorry, I missed a piece. Sorry, that's what 2 to the 30 is, but I forgot the 1 minus in front. So it's 1 minus 1073741,824. And it's over 1 minus 2, which is negative 1. That's 0.01 times, okay, 1 minus, that's 1 minus 1073741,824. Okay, that's negative 1073741,823. Let me move this. I'm going to need more room than that. And it's over negative 1. Okay, so 0.1 times that is negative 1073741,823 divided by negative 1. Okay, so all that's going to do is change it positive. So what I'm looking at here is 10,737,418 and 23 cents. Okay, so it's worth over $10 million. His first option was $1 million. His second option is $10 million. Okay, just by doing this thing that he says, 1 cent, 2 cent, 4 cent, 8 cent, okay, so doubling it each time for 30 days, it actually ends up being a massive amount of money. Ends up being over $10 million. Okay, that's the whole lesson there. Yep.